Okay, so much about the workflow bulletin and the content. Processing in Orthophoto is simple. You go to your photogrammetry part, go to create deliverables, and you always need, when you generate the automosaic, to understand we will always still calculate a point cloud. Even if you don't check on the point cloud, we will generate a point cloud. It will just not be written to your project of TBC, but we always run here a full process, and therefore this setting here has an influence on my orthophoto generation. Therefore, I will start with a digital terrain model on high. Why I'm using it, you can see it in a previous video. It's a fast process that still gets a very decent, good quality. And from the speed issue part, this is more than sufficient for me for this road construction. And then with this digital terrain model on high level, I will then generate my automosaic. And even if my point density here is something around, I think, 65 centimeter, I will still generate my automosaic in the highest resolution here with these 3 centimeters, because it will interpolate for each pixel on this 65 centimeter point cloud the corresponding height, and then generate my automosaic. If you do not measure or import your own boundary, we will use by default the US flight mission polygon, which is this one here. So this one here will then be used as our boundary. I have here now manually digitized a larger area, and I will use here this purple line here. I'm on purpose going here a little bit outside of this US flight mission, just to show if you expand your polygon yourself, you can also generate for the complete area outside of this, flight mission area, also your point cloud and automosaic. To select it for your output, just go to boundary and then click it here, and then it is selected in this case here. Then we will choose here terrain model high. I will now output this here into a separate folder and give here a name so that we can see here when I run it a second time with another product, we can compare these results. Okay, so here we go. If I want, I can make my background transparent. This is an alpha channel that is added, so besides your RGB channel, you can also then add a 4th alpha channel. And then this can be, for example, in Adobe products like Photoshop, can be imported and used. If you use the JPEG compression, then the background transparency is not working. So in the upcoming versions, you will see this will be grayed out. Just to be aware, this works only with TIFF. Main reason is the TIFF library that is used. So the standard TIFF library can use it. JPEG can't use it because TIFF JPEGs are storing it in a different way, and our libraries do not support this here. Okay, let's check. I use the boundary. I use the terrain model high. I output it here. Oh yes, I want to save my point cloud, and it jumped back. Okay, good to know. Just don't be aware if you check this, then go back and say again this is high. Or if you want to have it low, it's also possible, but then it will have a lower height accuracy. And then our automosaic will be written. In our case here, I use high as my output, and I will not generate a transparent background for it. And that's it, almost. Yeah, you have here another option is here to create your boundary yourself. This is just a function in TBC. This is the polygon function, rectangle polygon function. But you can also go to the cut functions and use all the cut functionality to measure your own polygon line here, or a line string if you want, you can also use here. And also the raster output. The raster output is an interpolation from your current point cloud, which means in my case here I am generating every 30 pixels, so 65 centimeter, a point, and then I can say, but I want then from this 65 centimeter dense point cloud, I want to generate a 2 meter raster, and then I could go here in and change then this value here and create a raster which is then based on the point cloud. Not important for us, because for us the point cloud is the important part used for my auto mosaic. Therefore I want to just check by the point cloud if this makes sense with my result. If I'm only interested in the auto mosaic, as I mentioned, you don't need to check it on. It will not be written, but it will still be calculated, just that we are aware. And that's it. Let's start it, and then after it's finished we will take a look at the result. So here we go, the processing is done. We hit import. We will now import this digital terrain model point cloud, and from the point cloud it's extracted auto mosaic, and they will be added to our project. So in the project explorer, when we go to imported files, we will now see here our Orthophoto, which is in this case the naming that we used here, so dtm auto.auto.tiff, and then the naming is also used for the point cloud, so dtm auto.pointcloud.las. When we take the properties, we can see in the properties here our pixel size that was chosen here from the resolution, the pixel width and height, so there we can see how large it is. Also here the megabytes, so 877 megabyte of size. Georeferencing is geotiff, so that means if we go to our project folder, then we can see exactly this Orthophoto and the point cloud. And when we go into the folder itself, so this is my output folder, but the folder itself, then we also see here one more time here this Orthophoto pasted into it. The point cloud stays in the DTM auto folder, which is here not copied into my project folder. And then we can also take a look at the point cloud, and in the point cloud you can see here these are our 5 megabyte size of our part, and if we go here into this part, then we can not see much. I just see here there's not much more in it. Let me just double check if there's more here. No, nothing here. Okay, so this is then our point cloud listed. Let's take a look at the data itself. When we go to the plan view, then we have here now, well, I go to the view filter manager, and I will now first switch off my point cloud. So I will switch off here the scans, and then we can now, and also my photogrammetric data. And when we take a look now here, then we see now the mosaic is generated with our 3 centimeter. And it's not causing us big issues in the flat areas. So we don't see here anything in a strong wrong way in this case. The only thing where we can then see it then is when you have let me see, yeah, for example here this car, the camera from this image was taken here from the right side, so it's leaning a little bit here to the left side because I can see here the window and I don't see the window on this side, and the same thing is here. So the projection centers are here more to the right side, which is exactly what we get. let me go here to the most further outside, and this is here. So here is my 2 images or 3 images are here, and then of course my viewing angle is from this side, and they are leaning now towards the left side here. But as mostly my interest is in the road, then the road here is well established in our 3 centimeter resolution. Let's take a look at the point cloud, and we switch on our scan, and then we go into the 3D view. Then we can here also take a look. Let me here close my deliverables, and let's make them side by side. So we can then here take a look at the data here, and then when we take a look here on this point cloud, so this is the point cloud that we used here for generating our orthophoto. And you see even the point cloud here is not perfectly on top of this blocking fence. The orthophoto is still correctly shown, mainly because it's not very high, first of all, and secondly also it's a little bit leaning to one side, but this is really not causing us a big issue here for our part. This is still nicely auto-rectified here for our product, and therefore no misplacements. If we go here, there's a little bit here a wobble effect here, so perhaps here the point cloud is not always on top or in the same height. And then also we have here perhaps a seam line going in. This could be, but in general, really very nice, good looking orthophoto along the road, and which is to expect because we don't have here problems. We see here in this area the point cloud is not correct, and if we switch it on and let me here go to this area here. This is here in the background here, and when we take a look here, then no surprise, we can see here the point cloud is wrong, and because the point cloud is wrong, then here our orthophoto is misplaced, and we can see this very good with linear features. So typically like these lines, and no surprise also buildings would be very nice to see when we have an issue. So that means if I switch off again the point cloud and we go to some objects that have linear parts in it, let's perhaps take a look here, this part here, and then we can see here the bending of the building here. This is then of course again because the point cloud is not here on top of the roof, but it's here on the ground, and therefore this causes then a misplacement, and it's still not really bad. So, but if you have many buildings, this would then be an issue. Same thing as here, misplacement, of course here down you can see it also a little bit more. This is then due to our coarser point cloud, which is this point cloud that we have here. You see also that objects on the road are trying to be avoided, so the terrain model tries always to stay as low as possible, especially smaller single objects that can be avoided are avoided. So also these cars here, we really try to have the terrain model included here and not a digital surface model. So the same is also with the trees here. If possible, he tries to stay on the ground. This is depending how dense the trees are or the forest. You can do it better or worse. In our case here, this is not so bad how he did it. Okay, so let's close here the 3D view and let's go back to the deliverables. And now in the next step, we want now to generate a digital surface model. and also create now our orthophoto on the highest resolution. And the difference will not be the orthophoto so much in its quality, but more in its geometric quality. So that means here, especially here, this part where we have this wobble effect here, I assume this will now be fixed because we have a denser point cloud that is more straight on the ground. This will be fixed in this case here. And well, this is almost here the main part. Perhaps here this blockage part will be a little bit more lesser leaning. Also the cars will lean less. We will still see some issues with the cars because there's some the material on cars is reflective, and therefore the matching on cars is not that easy. So therefore this will then probably be a little bit my advantage. And then of course, if we would have here stronger ditches inside here, then this could have an impact, but we don't have much here that can make here a big difference. I think there is the main part we will see here in this road part that is here on top of the hill. So this finishes now the orthophoto generation from DTM. I recorded the whole part, so therefore I was now cutting here in between, and will now in the next video show the orthophoto generation from the DSM. As mentioned, we will then see in the road how the denser point helps us to avoid this wobbling effects, and also how the leaning effect will be reduced with the DSM approach. So thank you for watching and have a nice day. Goodbye.